Okay, let's see another example. We're given our function. It's restricted to greater than or equal to 2. X is greater than or equal to 2. And we want to, we're going to do the same three parts. So we're going to prove f has an inverse, state the domain of f inverse, and find the derivative. So part A, the first thing we want to do is see if the first derivative is increasing or decreasing and continuous. Okay, so what is the first derivative of this? 2x, what, minus 4? And we're going to say if x is greater than or equal to 2. So f is increasing from what, 2 to infinity? Bracket 2 to infinity. Hence it's 1 to 1 and has an inverse. Alright, let's now use our algebra to find the inverse. So the first thing we want to do is write this thing as our original function is y equals x squared minus 4x plus 5. Okay, this is in standard form. Remember, let's see, standard form, which is the y equals ax squared plus bx plus c. Okay, we want to rewrite it so that it's in vertex form. Let me remind you what vertex form is. So that's going to be x minus 2 squared plus 1. Oh, that's going to be our answer. So our vertex form, sorry, is y equals a x minus h squared plus k. Okay, so that it's in this format. So what we want to do is take this thing from standard form to vertex form. So if you haven't done that in a while, let's practice with that. So we'll have y is equal to x squared minus 4x. Now we want to be able to make that a perfect square. We're going to kind of just shift this 5 over a little bit. We are looking for this value right here. And remember, we recall that we take the b term, divide by 2, and square it. So just off to the side, a side note, to find this, you will take the b term, divide by 2, and square it. In our particular example, what would that be? What's our b term? Negative 4. Negative 4 divided by 2 is just going to be negative 2 squared. Negative 2 squared, which is going to be positive 4. Well, if I add a 4 in here, I'm on the same side of the equal sign. I'm going to subtract out 4 over here so that I'm not changing the value. I just want to change the form. Okay. Now this becomes a perfect square. What multiplies to give us positive 4 adds to give us a negative 4. Yeah, what I accidentally wrote down a minute ago. So x minus 2 squared plus, and then what's that simplify to? Just 1. And this is for when x is greater than or equal to 2. We're going to remember our condition. Now, we can actually tell the vertex from this. If you recall, the vertex is going to be just opposite 1. So the vertex would be 2, 1 here. 2, 1. Alright, so now let's take this form right here, now that we're in this format, and find the inverse. So we want to interchange our x and our y. Because up here we had multiple x terms. We had an x squared term, we had an x term. It would have been really complicated. Now we have just one term that's dealing with x, and we can interchange x and y. And then solve for y equals. So let's subtract 1. This would be x minus 1 over here. Okay, so how do we undo this square? Take the square root of both sides. Square root. So you're going to get plus or minus the square root of x minus 1 is equal to y minus 2. And we're trying to get y by itself, so let's add 2 to both sides. So we're going to get f inverse of x is going to be square root of x minus 1 plus. 2. And why do we not use the negative one? Because we're restricted, right? So just to the positive value up here. So we have our f inverse of x. And now part B, okay, we want to know the domain, what was it? The domain of our f inverse. So that's the next thing you want to do. Okay, first of all, f has a minimum. We set our vertex. We actually found our vertex over here to be 2, 1. So that's where the minimum will be. And we're only looking at the right side of the graph because it's greater than or equal to 2. So the range of our original given function f is from 1 to infinity. It's the y value. Okay, thus by that theorem we have the domain of our f inverse is equal to 1 to infinity as well. Or you always have your graphing calculator. If it helps you to see visually, then you can look at that in that respect. Okay, just to bring all my information on the same page before I calculate, this is my given function, this is what we calculated to be our inverse, and this was our first derivative for part A. We'll bring that over here as well because we'll need it. And then my formula for the derivative of f inverse. So we'll have 1 over, let's do f prom, plug in our f inverse of x. So let me do that in red. So that's going to be the square root of x minus 1 plus 2. Okay, now what we want to do here is we want to go to our f inverse function and plug this in everywhere that there's an x over here. Okay, color coding as much as possible. I bring my 1 down. I go to my f inverse function, which is this 2x minus 4, and put a parenthesis everywhere that there's an x. Now I'm going to plug this red into the x location. So that's just going to be square root of x minus 1 plus 2. Okay, let's bring our 1 down. Now let's distribute here. So 2 times the square root of x minus 1 is just going to be 2 square root of x minus 1. What's 2 times 2? Plus 4. And then we have the minus 4. So what happens to these two? They're going to cancel out, and we would just be left with 1 over 2 square root of x minus 1. Okay, of course you could check this by going to your f inverse. If we correctly did our f inverse, then the check on this is pretty easy. Take the derivative of this and you should get the same thing. Okay, our next example is going to be a little bit different. Part A, we've done this before. We're going to use our first derivative to prove that it has an inverse function. And then for part B, we're going to find the slope of the tangent line at the point P on the graph of f inverse. So our given function is this, and this is the point P that's on our f inverse function. Okay, so for part A, what do we do for part A? It says use the first derivative. So first derivative shouldn't be too difficult here. What's the first derivative of this term? Term for term, is that 0? What's this one? Negative 1, good. And then what about the last term? Negative 3x squared. Now let's algebraically, let's pull a negative out. So that's just going to be 1 plus 3x squared. Because we can see that this entire term is going to be negative. That just means less than 0. So that tells us that f is decreasing. And it's continuous and decreasing. Therefore, f inverse exists. So we know f inverse exists. Okay, and the next thing we want to do is be able to find the derivative of our f inverse using the given information. So that's the slope of the tangent line is our derivative of f inverse. And we're going to do that on the next page. Okay, so we're going to take the derivative of our f inverse of x. By definition, we have that, but in this problem, we were given a point when the x value is negative 8, so we would plug in F inverse, our x value is negative 8. If I carried this down, I would just have f prom f inverse of negative 8. Okay, so at that particular point, which is going to be the slope of the tangent line at this point, what is the f inverse evaluated at negative 8? Well, this is our f inverse. When x is negative 8, what's the y value? 2, right? So I just bring down my f prom, and this f inverse evaluated at negative 8 is simply 2. Okay, so this is what we want to calculate. Now we have our first derivative. Let's pull that from the previous page. Okay, so our first derivative pulled from the previous page. So we want to evaluate, in red, I'll put my first derivative. So I have negative 1 plus 3. Everywhere there's an x, and we'll put a parenthesis squared. And what do we plug in place of that parenthesis? 2. Good. So now let's calculate that. So this would just give us 2 squared is 4 times 3 is 12 plus 1 is 13. Negative 1/13.